warahmatullahi wabarakatuh. My name is Muhammad Khairul Othman. My ID number SC18012. In this video, my group will talk and show to you about ceramics for bio-implant application. Before that, do you know about bio-implant? Okay, bio-implant in a general term for any implantable prosthesis made of biosynthetic material which is used to replace, support or enhance a falling structure. For example, like dental and bone implant. Okay, next, I want to explain and talk to you about the introduction of this application. Okay, ceramic that has been used for bio-implant application is known as bioceramics. So, what is bioceramics? Do you know about ceramics that has been used for bio-implant application? If you want to know, let's watch this video about ceramics for bio-implant applications. Okay, ceramics are now commonly used in the medical fields as dental and bone implants. Surgical ceramics shall be used periodically. Joint replacements are typically coated with bioceramic compounds to minimize wear and allergic reaction. Other examples of medical application for bioceramics include pacemakers, kidney dialysis devices and respirators. Global demand for medical ceramics and ceramic products amounted to around $9.8 billion in 2010. So the cost for these applications is very expensive. Okay, for the next part of this video, my group mate will focus for bone implant for this application.
Hello everyone, my name is Sugaseni Sounderajan. So today I would like to present about the composition of ceramic has been used in bio-implant applications. The most common ceramic used in bio-implant is hydroxyapatite. Common bioceramic are alumina, zirconia, and a form of calcium phosphate known as hydroxyapatite, a form of calcium phosphate that occurs as a mineral. It is chief structural component of bone and teeth. The inorganic phase of bone is composed by calcium phosphate, predominantly in the form of hydroxyapatite, corresponding to 65 to 70%, and bone water with 5 to 8%. Hydroxyapatite, one of most important organic material with excellent biocompatibility, affinity for biopolymer, and high osteogenic potential. An important characteristic of hydroxyapatite is its stability when compared to other calcium phosphates. Hydroxyapatite form the major inorganic portions of bone and teeth tissues, and it is a key requirement for developing bone grafts. The compatibility nature of hydroxyapatite with biological tissues regards as superior to other artificial materials. This is the hydroxyapatite. The formula and the structures. This is in the powder form. These were taken under the SEM micrograph. The source for hydroxyapatite is also known as eggshell. Eggshell represent 11% of total egg weights and is composed of 94% of calcium carbonate, 1% of calcium phosphate, and 4% of organic matter. It is economically cheap and plentiful in nature and has shown to be biocompatible with the human body during implantation. This bio-based eggshell can effectively be utilized for synthesizing pure nano-hydroxyapatite powders. The calcium phosphate or hydroxyapatite is the principal component of nature bone in the body. Ceramics made from synthetic calcium phosphate can also be used in medical applications. The problem is that these ceramics are not strong as alumina or zirconia ceramics. Zirconia bioceramic do not have high wear resistance of alumina bioceramic and are not as widely used in hip joint applications. However, their fracture toughness and bending strength give them additional qualities. Calcium phosphate ceramic can bond in bones and promote bone growth at their surface. A popular use of this ceramic is as coating on dental and orthopedic implant. For example, titanium tooth root packs and coat with hydroxyapatite, a form of calcium phosphate, give a longer lasting implant that bags that have been glued or cement in place. The hydroxyapatite binds chemically with living bone because it is a bioactive ceramic. This picture clearly shows the similarity in structure between human bone and hydroxyapatite. The synthetic hydroxyapatite based on orbital implants. For the formula, hydroxyapatite is Ca10PO46OH2. The bulk density is between 0.6 to 0.7 gram cm per cube. The specific weight is less than 2 grams. The porosity is from 70% to 75%. The pore size by SEM micrograph is from 100 to 300 micrometer. The unit volume is from 3 to 4 cm per cube. The flexural strength for solid hydroxyapatite is less than 25 megapixel. The compressive strength for solid hydroxyapatite is also less than 120 megapixel. The size is with any size, for example 14, 16, 18 or 20 millimeter. The shapes are in spherical, colloidal or any others. The types of hydroxyapatites are eviscerations or enucleations.
Okay, so Assalamualaikum. So my name is Nurhuda Fatinah binti Abdul. So my ID number is SC18017. So I will present about the mechanism of the application. It is about how ceramic works in the technology. So let's take a look. So first I will tell you about the major application area that we'll use in this technology. So the first is replacement for hips, knees, teeth, tendon and ligament. So next is about maxillofacial reconstruction, augmentation and stabilization of the jawbone, spinal fusion, bone repair after thermal surgeries, pyrolytic carbon coating for prosthetic heart valve, and repair for periodontal disease. So next, the next point is about ceramic femoral head. It is hip joint ball. So ceramic implant is inertness in biological environment and biocompatibility. So this produce nearly no debris, and the design are match the material properties of the bone. So it will look like the real bones. So ceramic can be tethered. So this point refer to the bone that it will allow bone to grow within their porous structure. It is scaffold. So it will completely incorporate the scaffold with natural bone within 5 to 7 months. So we can see here that it will take time for 5 to 7 months. So for alumina and zirconia based ceramic implants can be used on both for the ball and socket component of an implant, such as the femoral head and the acetabular cup of the hip joints. So this alumina and zirconia are harder than metal and have higher scratch resistance. So alumina and zirconia can withstand the harsh environment of the human body. So next. So this is the picture for the ceramic hip prosthesis provide much longer life, reduce the side effect, and it is suitable for patients, especially for younger people that require a longer healthy life without revision surgery. So the picture for A is for metallic and the picture B for ceramic alumina. So the major component of bone are hydroxyapatite and collagen fiber. So we have used hydroxyapatite ceramic as a bone substitute for grafting in extensive bone replacement. So hydroxyapatite is composed of calcium phosphate and is incorporated into bone as a physiological mineral. So it was usually employed to fill defect after removal of bone cysts and for long fusion in patients with scoliosis. So after removal of bone cysts, it will form a defect on the bone. So it will fill bone defect after trauma, for non-union in the lumbosacral area, for anterior vertebral fusion, in limb sparing operation for malignant bone tumor, and in exchange operation after failed joint endoprosthesis. So next. So this picture is about the example of ceramic surgical implant. So the human pelvis, which is often replaced artificially, has a unique bell shape. It is to support our upright bipedal posture and movement, and must be able to undergo a great deal of compression. So YTZP is the ideal ceramic material for constructing artificial bone because it have a high strength and toughness. So this YTZP, because of this quality, YTZP is unlike other ceramic bone material. It can be used without any metal for support.